Welcome to Spring LIB.
So in this question, we have 3 different parallel plate capacitors, and they have area A1, A2, A3, and they have separations D1, D2, and D3. So now we only have equation 2, which is definition which is determination of capacitance. And from this equation, we want to prove number 3. We want to prove that for parallel capacitors, the equivalent capacitance is equal to the sum of all the capacitances that are connected in parallel. So starting from the definition, we have Q equals C times V if we rearrange it. And since we already know that C equals epsilon naught A over D, this can be changed into epsilon naught A over D times V. So this is amount of charge. And for capacitance 1, so when they are connected in parallel, you can see that they share the same voltage. They share the same voltage V, but the charge of them is up. So this equation for Q1, it equals A1 D1. For Q2, epsilon naught A2 D2. And for Q3, it equals epsilon naught A3 D3. So they all share the same V. But then the total charge Q total equals Q1 plus Q2 plus Q3, which is epsilon naught A1 over D1 plus A2 over D2 plus A3 over D3 and times V. So now we can see that this is just C1, this is C2, and this is C3. So this equals C1 plus C2 plus C3 times V. But Q total also equals C equivalent times V. So from this equation, we can see that C equivalent equals C1 plus C2 plus C3.